So in the testament of DOROT, this is the Condor, and here we can demonstrate how the Condor operates. And if we take a look on the EC valve that we've talked about earlier, we have the closing solenoid and the opening solenoid. Flow goes from left to right, as it always. We have here a pressure gauge so that we can actually see and compare what we see on the application and what we see on site. And if you just give me a moment, and I will share my screen so that you can see how the Condor works with the application. Okay, so this is all the Condors on beta site that we use. I have this unit called the test bench, and as you can see, the unit is here with me. And we've made a special configuration for today, demo June 10th. We have defined a few sensors. The sensors that we will concentrate in today will be pressure sensor at the downstream, P2, and the flow sensor. The scenario that we will describe will be, as I said before, how we will change the set point according to the flow or according to the demand in the pipeline. And so we will concentrate only on these two sensors. I have a valve, S300 valve, as you can see here. This is our S300 valve, 100 millimeter. And as I said before, the Condor application gives us a lot of functionalities and is very, very flexible. So here I have defined, and you will soon see, I've defined a scenario which I have a burst in line, which I have overflow and something went wrong, and the flow will be above 120. At this point, I will want the valve to close, to shut down, no matter what. Okay, so this is one flexibility that allows me to do. We were talking about the Condor able to control 5 functions at a time. I'm not going to demonstrate the 5 functions at a time, but I'm showing you here the file that actually allows me to do it. I have 2 more functions to go. We have the data logger, the relay logger. I can actually be here for 2 hours and more, but we will not do that. So we are talking about the configuration of pressure reducing by the flow, okay? So as we said, the set point can be dynamic. We talked about set point by time. We will not demonstrate it today. And we talked and we will demonstrate set point by reference sensor. Just a second. Okay, so let's see the chart. The x-axis is the reference sensor, meaning the flow. As the flow goes from 0 to 80, the pressure the set point pressure will be rising linearly. As the flow keeps on climbing, the set point will stay on 35, if I remember correctly. Let's see. Yes. Until 100 cubic meter per hour. Then the set point of the pressure downstream to the valve will be rising to 40 meters and will stay steady. Now, if you remember, I told you that once we have too much overflow in the system, meaning that we have a problem, the valve will shut down. So let's see how it goes. Okay, so we're back on. So as you can see here, this is my HMI. I'm on monitor mode, and I can see I have 2 continuous solenoids, one for openness and one for closure, and it's connected. I did not connect and I did not define my latch solenoid. This is the valve current status. The valve is regulating, it's on keep position, meaning it's not opening any solenoid valve because we are close enough to the set point. My reference sensor says 35 cubic meter per hour, and I will believe him that the set point is supposed to be 13. Now we will increase the flow in the system, and we see that the set point changes. If you remember the numbers, we're supposed to get up to set point of 35. Okay, steady 35. You see how the pressure rises at the downstream of the valve. And as the reference sensor keeps climbing, the set point stays put, as we saw in the graph before. Now it changed to 40, and on 120, the valve will close. Let's see the solenoid. And the valve is closed.